Hey Shadu, do you
Yes.
found out our water bill for this month?
I don't know about that. Oh.
Actually, I found the bill from Weiqi just now. It cost about 40 ringgit for this month. Last month only about 30, if not mistaken.
I think that's impossible, right? Cause last month Penang have water shortage for 5 days.
Okay. If that's the case, will it possible that our water tank is facing leaking problem?
I think they're possible, but it's very difficult to detect that there's water leakage in our house.
Yeah. Or maybe someone used a lot of it. We also don't know. Is there any way for us to like make a features check it?
I think in CPC357 we had the IoT kits from brightest and Citron, right? I think we can build something IoT solution for this.
Sounds good. Should we have a try?
Sure, let's go.
Hi, Dr. Nadir and Dr. Chong. We are from Group AA, and our project is about an IoT application that helps with water monitoring in the house called Smart Water Tank Monitoring System. In this system, we are able to trace the water level in the tank, checking the water quality in real time. Like a normal water tank, the Smart Water Tank Monitoring System can control and fill the water automatically to make sure that the water is always enough for the user. Accompanied with a button that allows user to stop the water filling process. If any emergency situation is met, the user can press the button to stop the water filling. With further analysis to the data, we can then predict the water usage for the user, identify the peak usage, and the factor that might increase the water usage. If anything happens to the water quality, the system can also identify it immediately and inform the user through the dashboard so that the user's water source is always safe to use. With Smart Water Tank Monitoring System, users can have a better management toward their water usage and also ensure that their water are safe to be used. So now, let's have a look for how it works. For the setup of Smart Water Tank Monitoring System, first we have a servo motor SG90 at the top of the tank to illustrating the ability to help open and close the water filling process. Then we have 3 non-contact liquid sensors placed at the high, medium and low position of the tank that help us to identify what is the water level of the tank in real time. Next, we have our DHT11 placed at the side of the tank. The purpose of the DHT11 is to help taking the data of the environment. Next, we have our pH meter. It will be used to check the pH value of the water tank. Lastly, and there is actually a button down here that used to stop the water filling process if any emergency situation is met. The following part is the demonstration of our IoT application. But for the demonstration purpose, we just place the pH meter at the top to take the data. But in real case, it should be placed at the bottom like how it is shown just now. First, as you can see, all the water level sensors is not light up, which indicate that the water of the water tank is low. When the water is low or medium, the servo motor will control and start the water filling process. Until the water level is high, then the servo motor will stop the water filling. Meanwhile, the pH value and the environment data will also be traced by the pH meter and the DHT11 and show it on the dashboard to visualize the water condition. When consumers start using the water and the high level sensor is light off, the servo motor will start the water filling process again. Let's say there is an emergency happen and the water is need to be stopped filling. We can press the emergency button down here and the servo motor will stop the water filling process until someone press the button to activate it again. The same action can be also done through our V1 dashboard to stop the water filling remotely.
Now I will demo about the intelligent part of our Smart Water Tank Monitoring System. This is the workflow configuration to generate the module for prediction later. So in the data source here, I will select the Smart Water Tank Monitoring, which compound of pH, water level, temperature, and humidity sensor value. And as trending module here, I will select the temperature, humidity, timestamp, and pH for the input variables or features. And the target variable or labels will be the water level, which is our prediction later. And then I will test it. So in this regression workflow, in the beginning, it will fetch the data from the data source and then replace the missing value, change the types, and also split the data. And the data will be go to the training to generate the models later. Alright, it has been done. The model will be stored and used for prediction later. Inferencer. So the data source will be the same. Alright, since it has been done, let us see the result. Alright, I have export the prediction from V1 to Excel sheet. So the first thing that I want to know is based on the timestamp, which means what time will have the highest water usage, or in other terms, is the lowest water level. So let us sort the prediction for. So the 0 means there is no water in the water tank, and 1 means there is low water in the water tank. So we start from around 450 feet till at 02 p.m. Which means during that time we'll have no water or low water in the water tank because of they are using the water in highest rate than the water filling rate in the water tank. I think that's all. Thank you.